Today we're going to look at horizontally launched projectiles. Horizontally launched projectiles are objects thrown off of cliffs, objects that are launched at some angle. We are going to look at one scenario only, and that is the scenario of it being thrown horizontally, where there is no angle involved. So let's say you're at the top of a cliff and you throw a ball off the cliff and it lands some distance away. From the edge of the cliff to where it lands, that is known as your range. Okay? Or your displacement in the x direction. How far it has fallen is your distance in y. Okay? If we kick the ball, let's say we kick it at a velocity we're kicking it horizontally, so that means it's in the x direction. Let's make it 15 meters per second. We know that causes it to land. We know, let's say we kick it off a cliff and the cliff is 120 meters high. Well, we know acceleration, and it's due to gravity, and it's 10 meters per second squared. Well, how long is that ball in the air? How long does it take to hit the ground? And where does it hit the ground at? Those are the two things we want to find. So let's look at the first, time. To look at time, let's look at what if we just dropped it? If we just let go and let it fall, the time it takes to fall is going to be the same as the time it takes if you kick it off the cliff, because the height of the cliff does not change. So, you know d is 120. You know acceleration due to gravity is 10. You know d is equal to 1/2 a t squared. So that's 120 equals 1/2 of 10 times t squared. So that's 120 equals 5 t squared. So t squared is equal to 120 over 5, which is, so 120 over 5, which is 24. So t is equal to the square root of 24, which is 4.9 seconds. So the time it takes to hit is 4.9 seconds. So that means that the ball is flying through the air 4.9 seconds. We know time is 4.9 seconds. We know it was kicked with a velocity of 15 meters per second. So now we're wanting d in the x direction, which is our range. So we know velocity is equal to d over t. So d is equal to velocity times time, which is 15 times 4.9, which is about 73.5 meters. So our range is 73.5 meters. So to work all these problems, you follow the same format. You have to find the time it takes to fall. That is the same no matter what. Then and it is always based on the height that it's being launched from. Once you find that time, you can find the distance it's traveled or its range. Or you can find the velocity of the object if you have the range and you know the time of flight.